My name is Rômulo. I am a master's student in computer science at the Federal University of São João, and today I will present the paper called The Things of the Internet of Musical Things. Musical practice has always been susceptible to technological changes, adapting to the novelties that each era provides, such as, for example, the replacement of mechanical devices by electrical ones, or even the addition of magnetic tapes in the recording process. Nowadays, these technological transformations continue to influence music, especially when using concepts from the Internet of Things, creating a field called Internet of Musical Things. Although IOMUC helps with remote rehearsals, streamlines the recording process, and allows the creation of participatory concerts, there is still no clear definition of how an object connected to this network should behave. In this context, this paper proposed software, hardware, and communication protocol standards that this device must follow in order to improve the user experience and make this field more widespread and easier to understand. Issues that prevent this standardization are also discussed. I'll go through all these themes, starting with the evolution of music over time. Approaching only the evolution from the technological point of view, there is a division into four distinct ages. The first one is called acoustic era, characterized by the exclusive use of mechanical recording device. Then came the electrical era, marked by the introduction of electricity, which resulted in the use of new equipment, such as microphones, amplifiers, and recorders. Soon after World War II, magnetic tapes were used to record audio, thus initiating the magnetic era. Finally, the digital era, which started in 1975 and continues today, has changed quickly and dramatically the way music is created and consumed, replacing analog sound with digital coding. Still in the light of the digital era, the 21st century has presented significant advances and they reflect on the music. The possibilities for recording, reproducing, and distributing music have become much more accessible. This led to changes in both production and music consumption, allowing not only greater public immersion in a concert, but also more effective participation in it. But what could be called a traditional musical thing? Musical devices take the most varied forms and can be acoustic instruments, which produce sounds from the manipulation of their physical structure, and digital instruments, which use electrical waves for sound generation, and augmented instruments, which are acoustic devices with expanded capacity thanks to the use of electronic tools such as sensors and actuators. According to your applications in music, we define musical things as follows. Musical instruments. For these sessions, the same definition used by Hornobstel-Sachs was applied, which is the most traditional in disciplines that require instrument classification. In this way, they are classified into string instruments, which produce sound by vibrating strings; wind instruments, where the sound is produced by the vibration of the air or by its passage through edges or reeds; percussion instruments, which use vibrations from extended membranes for sound generation; and electric instruments, which the sound is produced by electronic means like theremin. Audio equipments are composed by microphone, mixers, and amplifiers. Symbolical musical equipment covers tools that by themselves do not produce sound, but are capable of manipulating digitally. Examples are MIDI sequencers, which record, edit, and reproduce data that follow the protocol of the same name. Since this protocol is not the focus of this work, it will not be presented here. Effect units includes effect pedals, which are electronic devices that alter the original sound of audio sources. And still in this category, there are plugins and extensions for music softwares. Music edit tools, it is a section composed by tools that help in the music study and the musical practice together. Examples are instrument turners, metronomes, and software for music accompaniment. Finally, we have artistic performance edit tools like stage lights. And about Internet of Musical Things. Internet of Musical Things ecosystem is based on the idea of several interconnected devices working together and creating information flows to result in a musical environment. This infrastructure consists of hardware and software, among which are sensors, actuators, communication protocols, APIs, and cloud services. In this context, musical things are entities that can be produce sound and can be connected to a local or remote network. Thus, a musical thing can be any device in the musical production and execution that support activities such as audience participation, remote rehearsals, music e-learning, smart studio production, and others. To create a standard musical thing, we must take into account some aspects, starting with hardware. This device must be programmable to a single task and have an internet connection. It must also be a standalone device. If they assume this condition, energy consumption must also be taken into account. As we are talking about music and the arts, aesthetic thoughts are just as important as technological resources. As for behavior, it must be able to communicate with other devices on the same network and undergo remote updates. Data exchange between musical devices is perhaps the most sensitive and most difficult problem to deal with. What data are possible to share, and how to share this data are questions that have come up. For the standardization in the exchange of information, including musical ones, should happen. One possibility to go from a traditional device to one that fits in the IO-MUST field, it is to use IoT device as musical device, and another possibility is to adapt traditional musical device to be used with internet connection. It is worth mentioning that the effect units must be built in such a way that the user has the freedom to remove or insert control buttons and sensors in physical units and change the code that produces the sound effect in digital units. As for the challenge, let's start with privacy and security. One of the keys to the success of Internet of Things is the confidence in using hardware and software that rely on this technology. The same pattern should be repeated here. Therefore, those who enjoy these means must be sure that the data will only be used and transferred upon authorization. They must be encrypted too. Another challenge is about copyright, piracy, and sharing policies. Music practice is an activity that deals with intellectual property and copyright, in addition to commercial issues inherent in the music industry. Thus, it's very nice to share and create music together, but the regulation of a collective creation can be a challenge to be marked and the law. About technological challenges, we have lack of synchronization, latency, and low audio quality. There is also the challenge of synchronizing audio streams between devices that do not share the same clock time. Finally, there are issues related to the creation of new interface and the design of the equipment. And the main difference between IO-MUST and Internet of Things is due to its artistic application, but still some problems regarding the arts may arise. One is the excess of information and resources that can undermine the creativity and individual views of each artist. The incorrect use of techniques by the musician also appears as a problem, since very simple presentations can turn the musical thing into a toy, while complex presentations can run into the lack of infrastructure or difficulty of understanding by the audience. Among the social impacts caused by IO-MUST, the following stand out. Abundance of technology for one part of the population and continuous scarcity for another, submission of workers to large companies, and loss of individuality of thought. In addition, two other problems can be accentuated. The first one is non-heterogeneous access to technology, as people living in more densely populated territories have easier access, And the second one is the lack of infrastructure, which can lead to an increase in social cultural difference. Finally, environmental challenges are pollution, chemical composition of materials, consumption of renewable resources, disturbance in ecology, and health hazards. So, this paper presents the concept of IOMUST and point out one of its main problems, which is the lack of standard in design of the device present in the network, making it difficult to communicate and interact with objects created by different companies or that perform different tasks. As it is an incipient area, there is still no protocol that standardizes both the construction and the communication of this equipment, as well as there are no network infrastructures that support several devices connected to it. With regard to security, privacy, environmental, and technological issues, IoT concepts can be used in a generic way. Musical things allow the reprogramming of equipment, as well as the insertion of new sensors and actuators, causing a positive impact on the artistic environment, such as the reuse of instruments, audience participation in concerts, and expansion of creativity capacities. An important concept that we intend to disseminate with this paper is the importance of IOMUST for the creation of new musical performances and artistic expressions. All the concepts presented here are experimental and show what we think about how this technology can be adapted to be more accessible for artists of different styles and social classes, thus not intending to make predictions and statements about what this field will look like in the future. Thanks for listening, and questions are available.